All right, I'm going to start the class. Okay, and if the parents do last minute register, then maybe they're not able to get in class. All right, let me focus on today's topic first. This is about similarity triangle. Okay, uh, you know, two triangles were similar. We're trying to measure why they're similar, how to check whether they're similar. Okay, when we say two triangles similar, okay, this is two triangles, they look similar, but maybe they're different size, okay? And there was a two equivalent condition here, A, B, C, A prime, B prime, C prime. So you have angle alpha, and this is alpha prime. And that is yeah, this, so this will be, I'm saying this is alpha, this is beta, this is gamma, okay? Here's the gamma, and the beta prime, alpha prime. And the sides corresponding to A is A, that's a B and a C. And this is a A prime, and the B prime, and the C prime. So when we say triangle ABC, that means notation means similar to the triangle A prime, B prime, C prime, if and only if the following two one of the following two conditions are satisfied. So the corresponding angles are equal, okay, or the ratio of the corresponding sides are equal, okay. So those are two conditions are equivalent. We can show that. Then as long as you can show that the corresponding angles are equal, then these two triangles are similar. Maybe they're different sides. So the ratio of the corresponding sides, they're all equal to the same number, okay? And where we can use these important properties, okay? Look at the triangle, if it's the right triangle. If you look at the right triangle, then you have alpha, right? A and B and C, and here's beta. For the right triangle, you just need to look at one angle. Okay, this is alpha prime, beta prime. So triangle ABC is similar to triangle A prime, B prime, C prime, if and only if alpha equals alpha prime. Why? The reason is alpha plus beta is fixed. Okay, so you just need to look at the one. You just look at the corresponding angles at the one at the A or A prime. Okay, so this automatically implies B equals B prime. The reason is alpha plus beta equals alpha prime plus beta prime equals 90 degrees. It's a fixed. So if alpha is determined, then beta will be determined automatically. So for the right triangles, if we want to check whether there's similarity, just look at the angles. One pair of the angles, that's enough. Okay. And the most important applications here. So suppose you want to measure, something, right? You want to measure the tree, for example, right? This is a tree, right? This is a tree, and so what do we have? You cannot measure the tree is too high, right? The tree is too high, and it's hard to measure it directly. So what you're going to do is you can measure on the ground, right? So you suppose this guy is about 5 feet high, okay? And I also know that it's up from here to here is going to be 20 feet away, and from here to here is going to be, I can choose, well, it doesn't matter, let's say 8 feet, okay? So based on this information, can we tell the height, how high of the tree, okay? Tell how high of the tree. So let's think about this. This is a very important application. Now, you can do that when maybe in your backyard there was a tree there, right? You can use this idea to measure the tree. So this is a shadow. Here's a sun. Okay, so you get shadow. Okay. Okay, so based on this information, let's call this one the h, the height, right? So these two triangles are similar. Okay, this triangle 5 and 8 is similar to that triangle. This is H, and that is going to be 28. Okay, why is this two triangles similar? Because those two angles are same. Okay, alpha equals alpha prime. Okay, right? So that's why these two triangles similar. Okay, then the ratio that corresponds. Yeah, this will be equivalent to the ratio of the corresponding sides, right? 5 over H is going to be 8 over 28. Okay, so now you from here you can solve for H. I think it's 5, 28 over 8. And you can simplify a little bit. Then you can estimate. Okay, so you can estimate the angle. Let's see. You can use it and change the decimal form and divide by 8. So it's about it's 17.5. Okay, great. So it's about 17.5 feet high. Right. So it's about 17 feet high. So I don't know who just getting here. So I'm going to ask you to do the following problem. Okay, this is a triangle, and here's A, and the C, and the B, and the D, and the E. Okay, we are given the following information. This is perpendicular. Okay, we're given the information. AC is going to be 24. CE is going to be 12. BC is going to be 10. Find the D. Please work on this problem. Okay, so please work on this problem. Right. So it's by the same idea, right? This is a D. I call the X, right? So those two triangles are similar, right? Then this is a BC is a 10, right? And so those two triangles are similar. Here's X, here's 10. And so AC is going to be 24, and AE is going to be 24 plus 12, and 36. So you can say that X over 10 should be equal to 36 over 24. Okay. Then just be careful, Then you find the X. Okay. X is going to be not going to be 20. Okay. So X is going to be 36 over 24 times 10. 36 is right. Yeah. So 36 divided by 24 times 10. So this is again 15. Okay. Based on my computation, it's going to be 15. Okay. Yeah, 15, right? So just simplify, step by step. If you have a pen, you don't need to use a calculator, okay? For example, 36 is 6 times 6. 24 is going to be 4 times 6, right? So 6 times 6, 4 times 6, and then 6 canceled out, and 3 over 2 times 10, right? That's why it's 15, right? Great. Great. Right, so let's try another one. And this is also have to find the similarity of two triangles. So you have two triangles. Here's A, and B and C and M and N. All right, so we know that MN is parallel to BC. All right. I also know that AM equals 5, MB equals 1, AN equals 13. Find NC. I find this side, X. All right, so first of all, let's talk about similarity, parallel lines. So if you have two lines parallel, okay, so those two lines, they're parallel. How do you measure it? If this is alpha prime. So they are parallel if and only if alpha equals alpha prime. So you get the same angle. So those two lines are parallel. Okay. So those are two lines parallel. Okay. Alpha equals alpha prime. Then it's two lines parallel. Okay, that's the definition. So you use this property to how do you tell whether two lines parallel? So two straight line, you draw a line across that, and you have two angles. If those two angles, if alpha is not equal to alpha prime, eventually these two lines will meet somewhere, maybe very far away, but they will meet. So then they intersect. Then those two lines are not parallel. Okay, parallel lines means they never intersect to each other if you extend those two lines. Right, so using this property, can you find the two similar triangles? So MN is parallel to BC, so this two angle alpha, this is also alpha, right? And this is a beta, and that is beta. So they share the same angle gamma, right? So those two triangles are parallel, A, M, N. So you have to recognize two two triangles, okay? Two triangle or similar triangle. So this is two triangle similar, okay? So you are given N 13, M, and 5, okay? And do we also know AB? Yes, AB is AM plus BM. So that means 6. And this side will be AN 13 plus X. So those two triangles are similar, right? And using similarity of the triangles, the ratio of the corresponding side will be all equal. So that means, okay, 5 over 6 is going to be 13 over 13 plus X. Okay. Or, if you write the bigger triangle on the right side, or you can say that 6 over 5 is going to be 13 plus X over 13. Okay. So then you can, I prefer to use like that, 13 over 13 is 1. And X over 13. Then I move 1 to the left side. Okay. All right. And the 6 minus 5 is a 1. Then the answer is X is going to be 13 over 5. Okay. So this is not going to be integer. All right. So that's how do we figure out the similarity? How do we use the similarity of the two triangles to determine one side? Okay. Now this next one, it's a little bit difficult to recognize to figure out two similar triangles. This is right angle, okay, A, B, C. And I'm going to draw another line perpendicular to this. Okay, what I know is AB equals 63, BC equals 16. I also know AC equals 65. So this is indeed the right triangle. Sometimes you're not given this information. You can check that 63 squared plus 16 squared equals 65 squared. So this is indeed the right triangle. Okay, find the length BD. Okay. Right, I wanted to work out this problem, okay? And the point is you have to use two similar triangles to figure it out. Okay. Anyone have answers now? Okay, nobody has posted answer yet, so I was not sure you got it or not. Okay, there are a couple ways to solve this problem. Okay, the best way to solve this problem is the similarity of the triangle. Okay, you have to recognize there are actually three triangles are similar. Okay, so let's call this one alpha, right? So this is a gamma. Okay, alpha and gamma. Okay, and I'm going to put this is A and the D and the B. Okay. Okay, so this is alpha. Okay, because alpha plus gamma is going to be 90 degrees. So this must be gamma. Okay. Then another triangle. Yeah, I'm going to put it here. This is a yellow color, right? It's yellow. That's yellow. Okay. Another triangle. Let's use different color. Okay. All right. So here's a B, here's a D, and here's a C. So this is gamma. Okay. So we want to know what is X. B and D is X. B and D is X. Okay, X is M. A and D, I don't know what is A and D. But I know A and B, right? A and B is 63. Okay, but I know B and C is 16. Okay. So do I know D and C? I don't know. So I have to use as an original larger triangle. Okay, original larger triangle, A and C is 65, B and C is 16, and the A and the B is 63. And clearly this is gamma, this is alpha. So all of the three triangles are similar. Okay. So they are all similar. Then you have so many identities. You can use this to get X already. And X over 63, right, is going to be 16 over 65. Okay, so that's why X is going to be 16 over 65 times 63. Okay, so that's the answer. If you just want to find X, but you can also find the D and the C, right, and the A and the D using the other triangles. Yeah, this is also equal to D and the C over 16. Okay, and then you you can find the DC. That way. Anyway, it's X is already found out. Now, another way to solve this problem is, okay, let's go back to this problem. Okay, right? 65, 63, and 16. You want to find X. I know this is, at the very beginning, maybe sometimes you're not told this is a right triangle. But this is a right triangle because 63 squared plus 16 squared equals 65 squared. So we're going to talk about Pythagorean theory later. But if you know this is a right triangle, okay, then you know that the area is going to be half of 63 times 16, right? But this also, you can calculate the area 65 times h. H is the height of this triangle using the other side as the base of the triangle. So from here, you get x is going to be 63 times 16 divided by 65. That's what we got. Okay? Use a similarity triangle. Okay. So for practice, I wanted to work on the next problem. So this is right triangle. Okay. And so here A, B, and C. So AB equals 13, BD equals 5. I draw the line perpendicular to this. Okay. And BD is perpendicular to AC. AB is 16, BD is 5. So I want to find out BC. Okay, what is this X? This side is 5, this side is 13. Yeah, please work on this problem. If you have answers, just post in the chat window directly to me. Okay. Anyone has answers now? Give me the fraction, okay? But you have to show, find the two similar triangles. Well, Come on, anyone? I'm waiting for your answers. Andrew, can you figure it out? Crystal, do you have answers? All right, so the difficult part is to figure out two similar triangles. Let's step by step, right? How to find the angles. Now we did this similar problem already, right? We have several triangles here. So let's just write down all the triangles, okay? Draw the two triangles. So this is the A and the D and the B, okay? So BD, this is a 5. I don't know other side, okay? But at least I know AB, AB is 13. Okay, great. Right. Then the larger triangle. I don't need as a small triangle. Here's 13. Here's X and A and B and C. So those two triangles are similar. Okay. Right, but 13x, I don't think we are able to get AC here, but I need the other one. Let's say, look at the small one. Let's see what we can get. And the B and the D and C. For this little one, BD is a 5, and the BC is going to be X. Okay. So we have those triangles. Okay, let's see. All those triangles are similar. So ADB, ADB, and the large triangle ABC are similar. So BC is X, right? And so X over 5. Yeah, but this is the right triangle, right? So this side, we should know this side should be 12. This is not given, but you have to calculate by the simple Pythagorean theory, okay? Because this is going to be, 13 square minus 5 square is going to be 12 square, okay? So once you get that, then these two triangles are similar, right? You can say that X over 5, right? Yeah, this two step, right? X over 5 is going to be 13 over 12. Then X is going to be 13 over 12 times 5, and then multiply this out, and that will be 65 over 12. All right, so that is answer. Okay, so you needed to find the AD, to solve this problem. So the smaller triangle is not needed. Okay, great. So here's another problem, and this is going to be 1, 2, 3. Yeah, and here's how many pieces here. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, yeah, that's it. I'm going to draw the line, not exactly, okay? So what I want to know is, what is the area of this triangle? Okay. Yeah. So this is a 4 by 7, a grid of a unit squares. Okay. So this means this side is going to be 4, right? This side is going to be also 4, right? And this is going to be 3. Okay. All right, now I wanted to find the area of the region. Find the area of the shaded triangle. Right? Yeah, please Please give me the answer. Okay. Okay. My hint is you have to find the similar triangles. Then you can determine each side of the triangle. Then you can find the area of the triangle. So my hint is here, you have to find this x. What is x, right? Once you find the x, then you solve the problem. X times 4 divided by 2 is the area of the triangle. Right? No, you cannot say it's, you cannot see it. My sketch is very brief, it's not precise. So you have to calculate the height of the triangle, Michael. Right? You cannot see, oh, it looks like it's 3. No, it's less than 3. Right? Did you get it? Well, just find the two similar triangles, right? So this is a 1, right? This is a x, here's a 4. Come on, right? Another one is the bigger one. Right? Here's a 4, here's a 7. Right? These two triangles are similar. By similarity, they're similar, right? Similar. So x over 4 is going to be, right? X over 4 is going to be 4 over 7. So x is going to be 16 over 7. That's the answer. Okay. Now, once you get x, you get the area. Area is going to be half of x times 4. Right? It's going to be 2x, which is going to be 32 over 7. It's 2 times 16 is 32. The geometry of the computation is not difficult. You have to, later on, we're going to do some problems. You have to draw addition lines, okay, in order to apply like a Pythagorean theory. But here, you don't need to draw addition lines, but you have to recognize, figure out what pair of the triangles are similar, right? All right. Let's take a look at the next problem. Okay, this is a rectangle, okay, rectangle, and then I draw the line and draw this, okay. So A, D, and E, and the B, and the C, okay. So this picture is not a fixed dimension, okay. There's some freedom here. What I know is, yeah, this, so this, yeah, D is parallel, right? Yeah. So those are two lines. Those are parallel lines, okay? Here's parallel. Okay. So I know the area given the area of the first condition, the area of the shaded rectangle is going to be 4. Second, I know AC is going to be 3. Okay. Can we find out D and E? I should have said that the dimension maybe it's very long. You know, it's not uniquely determined. But this side is AC is going to be 3, A and the C and the B, right? But there is a possibility. I just show you a picture. Maybe D is a constant, but the area of the area of the shaded rectangle it's very long. Okay, so this area is still equal to 4. So if you make the rectangle longer, and then you have to move the line DE up. So in order to keep the same area, then this example shows that the distance between D and the E probably is a constant. Okay, so your answer to this problem will be D can be determined or D cannot be determined. Depends on the dimension of the rectangle. All right, so please work out this. You have to use you have to find the similar triangles. Maybe you have to introduce some variables. I already explained to you this problem. Look at these 2 pictures. They have the shaded region have the same area. As the height, the width of the rectangle will be all both 3. But the length of the rectangles are different. Anyone has answers to this problem? Oh, can I see the length? I think I showed all the pictures here. Maybe your screen on the phone is a little bit small. Okay, so yeah, let's go back to the original picture. This is the original picture. Okay, right? Yeah. Now this time, okay, you do have to introduce some variables in order to solve the problem. Okay, I call this one X, and I call this side, let's call it A. Oops. Where's my picture? And this side is B. Okay, so now you have a picture. Okay, this is X, this is A, and this is B. So this is a BB, right? So the triangle here, you have two little triangle. Here's A, and here's X. Another one, right? This is going to be 3. That's going to be B. So those two triangles are similar, right? So by similarity, yeah, that's similar. So X over B should be equal to A over 3. X over B should be A over 3. Okay. Right? Then X is going to be 3 over A times B. A times C divided by 3. But I know A times B is going to be 4. That's a given. Because that is the area that A times B is the area of the shared region, right? So that's why it equals 4. So that's very simple. Just, yeah. A times B is going to be the area. As you can see, right? All right, great. So here's another problem. This is a rectangle again. Rectangle, and then I draw the triangle. Okay, this is a B, that's a C, and the A, and the D. Okay, and that's point E. So we are given the following information. Okay. We're given the following information. BE is going to be 8, EC is going to be 2. So this side is 8, this side is 2. Okay, and we don't know C and D. Or A and B. But what we know is this is right angle. So this is the right triangle. Using that, are you able to figure out X? So again, you have to figure out, yeah, find out all the similar triangles. Oh, we have to find out the side. We have to find out the width of the rectangle. Find out AB, which is CD, which is X. Find that, the width. Okay. So the rectangle, the right triangle is inside the rectangle. Okay. My hint is you will see 3 right triangles there, and they're all similar. Okay, and use similarity triangle, you probably can figure out X. All right, anyone has answer? Well, I told you there was a three triangle similar, right? So different colors and put there, different colors. Right, this is one triangle, and they must be similar. Let's prove it first. Okay, this is a yellow, and the one, okay, right, this one. So we have a print of, we have several similar triangles. So why they're similar? Okay, why they're similar? Okay, let's put the in the, let's say, let's put it in this position. Okay, so this is 8, B, and E, and A. Now the small one also rotated, and it's going to be like that. And okay, so when I rotate it, this will be C, that will be E, then this will be D. And this side becomes X. This side is 2. Okay? But I think AB is also X. Probably that's enough. Probably that's enough. Okay? Right, these two triangles are similar. The reason is they're similar, if this is an angle alpha, right? And this will be beta, alpha plus beta 90 degree. Okay? Right? Alpha plus beta 90 degree. Okay. So 100% sure this should be equal to beta. And then that must be alpha. Why is beta? Because alpha plus 90 degree plus beta should be, alpha, yeah, this the sum of the triangle should be 90 degree because this is a 90 degree. Right? So the sum of the three angles would be 180 degree. So that's why this must be beta, because this must be beta. Okay? So these two triangles are similar. And then the ratio of the corresponding sides will be the same. 8 over x will be x over 2. Okay. So that's why x squared equals 16 and x should be equal to 4. Right? So we get 4. All I have to do is just find the two similar triangles. Okay? Right, so now here's another one, rectangle. A and B, C and D. Okay, I'm put the point P here. I put the M. M is the middle point, and here's a Q. Okay, I draw the line like that. All right, so we are given some information. Okay, so the angle PMQ, this is a 90 degree. Okay, 90 degree. M is the middle point. This is the middle point. Okay, and BP is going to be 4 over 3 BC. Okay. Wow. BP, PB, okay, is going to be 4 over 3 BC. Okay. Okay, that's information we need. Okay. Find the ratio PM to MQ. Okay. So we don't know the dimension. Okay. But we know that M is the middle point. So I could call it, and let's call it H, and then this will be H. Okay. And this, I'm going to call it, yeah. So that will be something, it's related, right? And this we call the PMX and the Y. And we want to find X to Y, right? Actually, this is the right triangle, right? So what we should know is, if this angle is beta, and then this angle is alpha, Alpha plus beta 90 degrees. Since here's 90 degrees, so this must be alpha. That must be beta. So you have two similar triangles. So PB is going to be 4 over 3. BC is going to be H double H, 2H. So it's going to be 8 over 3H. So I have yeah, let's say 8 over 3H, okay? So now you have two triangles that are similar. Okay, two triangles similar, B and the P and the M. And this is another triangle. Okay, so this is M. That is a Q, that's a C. So because this is alpha, that's alpha, right? Okay, so let's mark the corresponding side. BM, yeah, that's H. P, we don't know PM. PM is X. We know PB is 8 3 of H. Correct? So that is X. MQ is Y. Okay? MC is H. CQ we don't know. But that's it's not necessary. So look at these two. These two are similar. These two triangles, right? You find the similar triangles, then you write down the corresponding ratio. Okay. So, yeah, you have to prove that those two triangles are similar. Okay. Yeah, these two triangles are similar. So the corresponding ratio, 8 over H divided by H is going to be X over Y, right? X over Y. So then HH cancels out. So the answer is X over Y is going to be 8 over 3. Okay. So let me repeat what we discovered. Okay, if we have, okay, if we have something like that, okay, this is 90 degree, and then since this is alpha, if that is beta, then alpha plus beta is going to be 90 degree. Because of that, you can show that this angle must be alpha, because alpha, and if that angle is, we don't know, for example, gamma, right? We don't know what is gamma. And we know that beta plus 90 degree plus gamma should be equal to 180 degree. So that means beta plus gamma equals 90 degree, but beta plus alpha is 90 degree. So that means gamma must be equal to alpha using these two equations. Okay, so that's why, and then this is a must be. This must be beta. If that is alpha, then this must be beta because alpha plus beta. That's the key. That is the key idea. Then you have three similar triangles at different sides. Right? Then you have three triangles at different sides. Okay.